Welcome to this preview of our top class paper, Gradualizing the Calculus of Inductive Constructions. As you may have guessed from the title, we aim at bringing together two lines of research. The first one is on the Calculus of Inductive Constructions, CIC, which is a dependently tapped language or logic, and as such is the basis of many proof assistants, such as COC, Lean, or ACTA. On the other hand, we have gradual typing, which mixes static and dynamic typing discipline by adding a dynamic type to a static system, treating it optimistically during the typing phase, and compensating this with runtime checks, as is usual in dynamic type systems, during runtime. The work on this has been ongoing in the last 15 years or so, going up from simply tapped lambda calculus to more and more complex typing discipline. But no one has been able to handle full-blown CIC yet, which is exactly the problem we tackle in our paper. As to why you would want gradual dependent types, well, the answer is pretty much the same as for most gradual type systems, namely incremental development. If you've ever tried programming with dependent types, you know that they enforce very strict invariants, but that it may be quite frustrating to write them down, because you need to give completely precise types to your functions while you are still in the development phase. Here, for instance, you would need to give the length of the output vector of the filter function while you are still trying to write it down. What we can do instead is use the unknown here, so that you can start writing down examples or tests, evaluate them, and see that they would return either errors or values, while the type is still not completely precise. So in a way, the unknown works as a wildcard, but it has a computational behavior. You could not do this with an axiom because it would block computation, and in the end, these would not be typable. Beyond dependent types, we also were forced to reconsider quite a few ideas from the literature, so that this might be interesting for people from the gradual typing community, even if they are not into dependent types. As to the specific challenges that are posed by the adaptation of gradual typing to CIC, because of dependent types, there is no distinction between types and terms. In the previous example, the unknown was used as an index, so a term, and not only as a type. Similarly, there is also no distinction between typing and runtime phase, because you need to evaluate terms or arbitrary programs during the typing phase to compare types. Finally, gradual typing requires effects, at least errors and possibly divergence, and these are known to interact quite poorly with dependent types. For instance, in the last example to date, towards CIC, namely approximate normalization, computation is somehow degenerated during the typing phase, and there are also no inductive types, all of this to preserve the system from divergence. The degenerate computation still satisfies the gradual guarantees, but not the more precise property of graduality that has been put forward by New and Ahmed. So what's in our paper then to solve these issues? First, we don't have the perfect system, because we show a no-go theorem, which we call the Fire Triangle of Graduality, saying that we cannot have at the same time the graduality property I just talked about, normalization of the system, which ensures decidability of type checking and consistency of the logic, while having the whole CIC as a subsystem of the gradual system. What we have instead is one system that we call GCIC, with three different variants, each of which differ only on the way universe levels are handled, and each of which keeps two sides of the triangle while leaving out the third side. So the user can decide, depending on their needs, which property are desirable and which one they want to abandon. The way the system works is via a type-based elaboration. This is quite usual from the gradual literature, having an elaboration from the source language to a CastCalculus, but here the twist is that this is interlinked with typing. There is no separate typing in GCIC, because we need computation of the elaborated term in CastCIC to compare types and terms in GCIC. And finally, to justify the properties of CastCIC, we rely on a wealth of models, and the most interesting are order models, where the order relation interprets the precision relation of gradual typing. That's it for me today. I'll leave you with a small takeaway, and I hope to see you at the long presentation.